In this video, we will be looking at geometric series. So just a reminder, geometric sequence has a common ratio. So if you look at 2, 6, 18, you're multiplying by 3 each time. 2 times 3 is 6. 6 times 3 is 18. So that makes it a geometric sequence. And the general equation for a geometric sequence is an, which is the general term, equals a1, which is the first term, so in this case 2, times the common ratio, which is 3, to the power of n minus 1. And n is just the position number in that sequence. So a geometric series is when you add the values in the sequence. So 2 plus 6 plus 18, so on. Now there are two formulas. The first formula I don't use, but it exists, and that is if you take the term that comes after the last term in your series, so it's actually outside your series, subtract the first term and divide by the common ratio minus 1, that would give you the sum. But like I said, I don't use that one. The one that I use is you take your first term, so your a1, multiply it by the ratio to the power of n, subtract 1, all over the ratio, subtract 1 again. So let's try it out. Determine the sum of the first 10 terms of the geometric series given the first term is 3 and the ratio is 2. So n is 10. So I'm trying to find the sum of 10 is equal to a1, which is 3, the ratio 2 to the power of the number of terms we have, which is 10, subtract 1, all over our ratio, subtract 1. Okay, and if we clean this up a little bit, if I simplify my bracket, I get 1,023, and then 2 minus 1 is 1. Once again, we get 3,069. So the sum of the first 10 terms is 3,069. So here we were given everything. Let's try the next one. Determine the sum of the first 12 terms in the geometric series 1 minus 4 plus 16 minus 64, and so on. So I know that n is 12. I know my first term is 1. But now for my ratio, to go from 1 to negative 4, I'm multiplying by negative 4. And then let's just try it out. Negative 4 times negative 4 is positive 16, so that's perfect. So now the sum of 12 terms is our a1 is 1, our ratio is negative 4, make sure you put it in brackets, to the power of n, which is 12, subtract 1, all over the ratio, subtract 1. And now, if we clean this up a little bit, we have 16,777,215 all over negative 5 to give us a sum of negative 3,355,443. And that's it for that one. Let's continue. Determine the sum of the geometric series 5 plus 15 plus 45 all the way to 10,935. So we know our a1 is 5. I can see that the common ratio is 3 because I'm multiplying by 3 each time, but I don't know the number of terms we have. So we actually have to use our geometric sequence formula first, which is a1 r to the power of n minus 1, and we're going to use our final term to figure out what position it's in. So 10,935 is equal to the first term times our common ratio of 3 to the power of n minus 1. So I'm going to divide both sides by 5, and I get 2,187. Now, to solve an exponential equation, we're going to get a common base. So 3 to the power of 7 is actually 2,187. And then if I set my exponents equal to each other, 7 equals n minus 1. Bring the negative 1 over. We have 8 terms in total. So now that I have all of my information, I can find the sum of the 8 terms. So a1 is 5 times the ratio to the power of n, and then subtract 1 outside the exponent, and then r minus 1. You can do this all in one step if you want, or you can clean it up. So if I clean up my numerator, I get 32,800. My denominator is 2. So here is my total sum. The sum of this geometric series is 16,400. Okay, we're going to do the exact same type of scenario here, but we're going to see what happens when we have a fraction just to make sure we can deal with everything. So in this series, our a1 is 32. Our common ratio, well, to go to 32 to 16, I'm multiplying by a half. And then from 16 to 8, a half again. But once again, I don't know how many terms are in this sequence. So I'm going to use my geometric sequence formula first. So my last term is 1 over 8. And that's equal to my first term times the ratio of a half to the power of n minus 1. So our goal is to solve for n. So first thing, let's divide both sides by 32. And remember, dividing by 32 is the same thing as multiplying by the reciprocal, so 1 over 32. And we're going to get 1 over 256. And I want to keep it as a fraction because I am going to try to get that common base to solve this exponential equation. So to get 256, I know it's 2 to the power of 8, meaning if I do a half to the power of 8, I will get 1 over 256. Now, set our exponents equal to each other, bring the negative 1 over. We have 9 terms in total. So now we can go ahead and use our series formula. So the sum of the 9 terms is a1 times our ratio, which again we're going to put in a bracket, to the power of n, which we figured out is 9, subtract 1, all over a half minus 1. So we do have fractions here, so we're going to have to deal with them. So I'm going to clean this up in some extra steps. First of all, 1 over 2 to the power of 9 is 1 over 512. And I'm going to subtract it by 1, but I know with fractions to subtract in a common denominator, so I'm actually going to rewrite 1 as 512 over 512. All over, a half minus 1 is negative a half. And then 1 over 512 subtract 512 over 512 is negative 511 over 512. And here, instead of putting it all over negative a half, I know fractions mean division. So dividing by negative a half is actually the same as multiplying by the reciprocal. So this is what I want to do. But I can't divide fractions, so I'm actually going to multiply by the reciprocal, which is negative 2 over 1. So now I just have a bunch of multiplying. 32 over 1 times negative 511 over 512 times negative 2 over 1. And if you multiply that and reduce, you actually end up with 511 over 8. So that is the sum of this series. So when you have a ratio that's a fraction, or you have terms in there that are fractions, it could get a little more complicated with the simplifying, but exact same formula. All right, determine the number of terms in a geometric series if the sum is negative 63, the ratio is negative 2, and the first term is 3. So looking at our general formula here, so a1 r to the n minus 1 all over r minus 1, we're looking for n because that's what we don't have. But we have the sum, it's negative 63. We have the first term, it's 3. I know my common ratio is negative 2. and then negative 2 minus 1 in the denominator. And now I'm just going to clean this up a little bit. So I'm going to clean up my denominator because it is just equal to negative 3. And now I can actually simplify the fraction. So 3 over negative 3 is negative 1. So that helps me get rid of the fraction. And now we can divide both sides by negative 1. And that gives us 63. And now we can work inside that bracket. So we can bring the negative 1 over to get 64. And now we can go ahead and get a common base because we're at the point where we have to solve our exponential equation. So I know 2 to the power of 6 is 64, but I need a common base. So negative 2 to the power of 6 is also positive 64. And now 6 equals n. So there are 6 terms in this geometric series. And finally, our last example is going to be a word problem. So when Maggie was 9 years old, she read her first novel. Each year after that, she read triple the number of books. If this trend continues, how many books has Maggie read in total at the age of 12? So notice it says how many books she read in total, which gives us the clue that we are doing a series here. So we know that when she was 9, she read her first book. So let's say that's 1. And then after that, it triples. So times 3 is 3, times 3 is 9, times 3 is 27, and so on. And we're going from the age of 9 to 12. So from 9 to 12, that's 4 years of reading. So we're looking at 4 terms, okay? And we're gonna use our formula. So we know our A1 is 1, our common ratio is 3. Now technically here, since we only have 4 terms, yes, you can add the numbers, but imagine this had been more terms. So the sum of 4 terms is our A1 times our ratio to the power of n, subtract 1, and then the ratio subtract 1 again. So that gives us 80 over 2, which is 4D. And then because it's a word problem, we'll write our therefore statement. So therefore, Maggie has read a total of 40 books by age 12. And just a little thing here about our n value. You might say, well, 12 minus 9 is 3, so n should be 3. But think about this. Age 9, age 10, 11, and 12. Those are 4 different numbers. Because if you just do 12 minus 9, you're not including either the first age or the last age. So be careful with that. And then that's it for geometric series. So we have one formula that we use the entire time where we need our first term, the common ratio, and the number of terms we have in the series. And if we're not given one of those pieces of information, we can use the geometric sequence formula. So they're kind of, you're using both of them sometimes to get the full answer. And that's it.